Good morning, biology. Today we will cover 18.2, which is the second section of Chapter 18. Chapter 18, as a reminder, is on classification. This is a very short chapter, as you'll see. As we get into next Monday, we'll have this chapter finished up by Monday. So pretty short and quick one, kind of nice. So anyway, we talked about Carolus Linnaeus last class, and we learned that the method that he developed back in the 1700s was mainly used or mainly derived from just observations of living things. In modern day, we do it a little bit different, and of course, between Linnaeus and modern day, we had Darwin. Okay, so remember, Linnaeus started classifying these things way prior to the theory of natural selection and Charles Darwin's journey. So now that we know a little bit about how evolution works, that's the main difference in today's classification system. So we still look at similarities and differences because that's still important, but we also can look at evolutionary results. So now that we know about DNA and fossil record and things like that. So this brings up the term phylogeny, and phylogeny is the evolutionary history of lineages. So the goal here is to group species into categories that show those lines of evolutionary descent. And the next couple words should look very familiar: clade and cladogram, which we had in the last chapter. And a clade is a group of species that include a single common ancestor and then all of the descendants of that ancestor. A cladogram is a diagram that shows those things. So let's take a look at this. We've seen these before. This should be pretty easy. Okay. To further understand those cladograms, we need to define the word or the term derived character. And so you probably have heard of the word derived before, maybe in math class. So a derived character is a trait that arose in the most recent common ancestor of a particular lineage and was passed along to its descendants. So let's look at two creatures that you guys are fairly familiar with. We have a coyote, which lives in our area, and then we have a lion, which lives in Africa. But they are both meat eaters, and so we look at some of the shared things that these two animals have. One being specialized shearing teeth used to cut, tear flesh, tear through hide, maybe even kill or obtain a prey animal. Both animals also have hair. They're both mammals. They're also four-legged. One big difference, though, is the fact that lions and most cats have claws that retract, claws that can go back in, kind of stay hidden in their paw, whereas all dogs, their claws are non-retractable. Their claws are always out, I guess. So if we look at that same information in a cladogram, we can see how some of these groupings of creatures have come to be. So we start, I was on the left side, work our way to the right. And so evolutionarily, in history, 4 limbs. So remember how to read these cladograms. We find the character. And then everything after that node, after that spot, would include that characteristic. So 4 limbs: amphibians, reptiles, mammals, carnivores, cats. All of those have that. And so we can look at a box here. It's not really a box, but you get the idea. This is clade tetrapoda, and in science, pod or poda refers to foot or leg. Tetra, I was just actually playing Tetris last night, right? The game Tetris is named so because it has 4 blocks that make up every piece in the game. So tetra means 4, so 4 limbs. Our next node says amniotic egg, an egg with membranes, and reptiles, mammals all have an amniotic egg. Maybe not an egg as you think of it, but it is there. And so that's called clade amniota. And so clade amniota includes all of these animals except for the amphibians. The presence of hair defines clade mammalia. Specialized shearing teeth defines clade carnivora, any animal that would be a carnivore. And remember, dogs are carnivores, and also cats are considered carnivores. But in terms of clade felidae, the felines, dogs do not belong to that because they lack retractable claws. And so you can see that it's a very simplistic diagram, but yet at the same time it really causes us to think about how these creatures did evolve, and the similarities that they do share, but also the differences they have. So I like cladograms. I think they're an easy thing to look at, especially when they do the background grouping here so you can see them. I think it's a nice clean way to look at things. All right, so knowing that, let's look at a comparison of 3 birds here. So DNA and classification. Okay, now we can't look at these birds and automatically see their DNA, but we know that we can study it. So what do you think, or which do you think are most closely related and why? We have the African vulture, the American vulture, and the stork. Okay, so why don't you pause your video, take a few seconds to think about that, and then throw an answer out there. So pause now. Okay, you're back. So which 2 do you think are the most related? If you said African vulture and American vulture, you are wrong. The American vulture and the stork are actually more closely related than the African vulture and the American vulture, otherwise known as the turkey vulture. Interesting, isn't that? Very surprising. But the reason, looking at them physically, most people with any, common sense would just automatically go, well, geez, these are both vultures. They have naked feathered heads. They feed on decaying creatures. They're scavengers. But looking at DNA and also some other facts disproves that. Not that they aren't related in some way. But these have more similar DNA and also a unique feature, which many of you probably don't think about often, urinating on their legs to cool down their bodies. Okay, so it evaporates, the liquid evaporates from their legs, results in a cooling effect. African vultures do not do that. Okay, so they have a little more control, or I don't know what you would call that, modesty in terms of when and where they do that. Okay, so kind of an interesting thing. All right, another interesting look at this. Now, this diagram is not a cladogram, but it's another diagram that is used to show evolutionary relationships. And we can also look at the pandas. And I know we call the panda a panda bear, but maybe that isn't always a perfect way of describing them. Okay, but if you look at a giant panda and you look at a common black bear, I mean, a lot of us would go, yeah, they have a bear face, right? Raccoons, which we see often around our area, looks a little bit different, but they do have a lot of similarities with bears. There's also an animal called a red panda. And if you notice the tree here, they all have similarities. similarities. Both pandas share similarities with both raccoons and bears. Both pandas, however, have thumb-like wrist bones, opposable thumbs like you guys have, which allows us to grasp and hold on to things. Raccoons also have a very opposable thumb and a lot of dexterity in their paws. And so the red panda, notice here, is actually more closely related to a raccoon, where the giant panda is more closely related to a bear. And just because they're called pandas doesn't mean they're super closely related, or the most closely related two creatures, but they are related in a way. Here would be the common ancestor of all four, okay, at one point in history. And they actually grouped the red panda with raccoons, seals, and weasels. And we learn in field biology about the different kinds of mammal teeth and skull structures and things like that. And raccoons, seals, and weasels all have meat-eater style teeth. And so they have a very meat-based diet, although raccoons are, they take what they can get. They'll eat almost anything. Bears have a very widely ranged diet from plant life to meat, where giant pandas are pretty much a specialist in terms of how they eat. They eat a lot of bamboo and stuff. So, here we can look at some other things besides appearance to help us try to understand how things are related. All right, so that was a quick section. What I'd like you to do now that you've watched the video, go ahead, complete classification quiz number 1. 15 points, I believe. So take your time, do a good job on that, score some good points. This is a short chapter. We will finish this one up on Monday. It won't be a lot of stuff to talk you through Monday. I'm previewing a podcast right now. We might implement that also early next week. I'm still just trying to figure out how to do it. It's a great podcast, and it ties together evolution, classification, and also ecology, which is what we're going to do next. So it might be a nice little transition point. So I need to do some listening to it, figure out what we want to do with it. But have a good weekend. Supposed to be pretty nice weather the next few days. I saw some 70s on the forecast, so take advantage of that and stay healthy, and we will touch base next week. All right.